I've listed here 4 general properties of enzymes. Number 1, so enzymes catalyze reactions. And we know that catalysts speed up chemical reactions. So your enzymes have high reaction rates. But the magnitude by which they enhance uncatalyzed chemical reactions is greater than the magnitude from chemical catalysts. So for example, here, if we compare first the rates for non-enzymatic reaction rates, so the chemical reaction is taking place without the enzyme, we see that the enhancement is 10 to the 6 up to 10 to the 12. So this is how big the difference is. Now, if we compare the rate with the enzyme, and with something, a chemical catalyst performing the same or catalyzing the same chemical reaction, the enzymatic reaction rate is still several magnitudes greater than that with the chemical catalyst. So enzymes are really very powerful catalysts. Next, enzymes can catalyze these reactions in milder conditions. So in terms of temperature and pH, like in temperature, most of your enzymes can catalyze these reactions even at temperatures lower than 100 degrees Celsius. Some chemical catalysts require very high temperatures. Some would even reach 500 degrees Celsius or 700 degrees Celsius. In terms of pH, your enzymes also catalyze chemical reactions at milder pH ranges, while chemical catalysts can catalyze reactions but at the extremes. So they require very acidic conditions or very basic conditions. Third is that your enzymes have greater reaction specificity. And when we say greater, it's because an enzyme binds to a very specific substrate. Hence, it can give a very specific product. So, what's the consequence? You don't have any side reactions. Unlike in organic chemistry, you know that organic reactions, most of them can produce a lot of side products, and you don't want that. And the fourth one is the capacity for regulation. So enzymes, their action is not only dependent on the amount of substrate, but also in the amount of other molecules. And aside from this, they can also be regulated through what we call allosteric regulation. This has something to do with a change in the structure of the enzyme brought about by the binding of another molecule. Another way by which you can regulate the action of an enzyme is through modification. So a classical example is phosphorylation. So there are some enzymes at specific amino acid residues, they get phosphorylated. Some enzymes, if they are phosphorylated, they are in the inactive state. And once the phosphate group is removed, they become active. Some enzymes have it opposite. So they are active they are active with the phosphate group and inactive if they are not phosphorylated. So there we can see a lot of enzymes being controlled or regulated through these mechanisms.